Good evening, everyone. My name is Karandeep, and today we are going to discuss our project on behavior risk factor. This is the weekly status report 7. The dataset includes data on adults' diet, physical activity, and weight status from behavior risk factor surveillance system. This data can be used to make trends and even further predictive modeling, which we have done in our project and will be explained further. This data includes data on national and state-specific on obesity, nutrition, and physical activity, and even certain habits of individuals like smoking. Our curiosity was mainly regarding the depression levels in individual, which was related to these habits, and also on the smoking level of the individuals. We have done a report and used predictive modeling for this purpose. Moving further, we have the table of contents, everything which is covered in these slides, team profile, project status, activities since last project, timeline and communication, and the task which we have completed. This is a team profile. Lakshmi is the Python developer in our group, Karthik is the lead, and I am the data analyst. The project status is that we are on track, we are done with the development phase, and now we'll be moving further. Activities which we have completed since the last report was updating the SharePoints, completing our development phase, and moving towards the dashboard, which will be done in the Power BI, and then a report will be created upon these analysis. This is the timeline of the whole project. It started on July 14th. We are done with the requirement, design and development phase, and now we are moving towards the testing phase. So the issues or the challenges which we faced. The major issue which we faced was the date issue, as the data column was in the year, and does not have any month or quarter in it. When we use time series decomposition for our predictive modeling, it requires a date in a month or quarter, but that was not possible. We even tried doing it, but it shows that it needed a specific period to perform the further analysis. So to solve this problem, we moved towards a linear regression. Linear regression was suitable for our scenarios because we have multiple independent variables which we have used to create a relationship and get the analysis. The communication was done using mostly the online platforms. The models which we have used for a data analysis purpose. The time series which I have told you earlier was used because we can in which we have used ARIMA, an autoregressive integrated moving average, which means it used data from the previous years and help you predict the future. This can provide sometimes inaccurate information if the data is not well analyzed and cleaned. It makes use of lagged moving average to smooth time series data. The next model which we have used is the regression model, which we have told you earlier. It uses multiple relationship, both dependent and independent, to create an analysis. And also we have used various statistical analysis in a project like hypothesis testing to understand the relationship between variables of significance of observed patterns. The further analysis will be explained by Karthik.
Hi, thank you, Karan. Now I will be walking us through the codes and various graphical representation which we have created to demonstrate the visualization and demonstrate the analysis. In the following slides, we will be going through various Python snippets demonstrating powerful data visualization and predictive analytics techniques. Using popular libraries like Matplotlib, Seaborn, Stat Models, and Skitlearning. Beginning with the code to visualize the top 50 question IDs by the frequency in a bar plot, I would emphasize how this representation offers a quick insight into the most frequent inquiries. So as we can see, child count, material rate, employee health, general health, and age and smoking are one of the biggest factors. As we move further, we have a heat map. To display correlation matrices. This visualization would depict the strength and direction of a relationship between variable through color, gradients, and annotation, helping us identify potential dependencies and interaction within their dataset. Now, as we transition to the time series analysis, I would detail the step-by-step process of using linear regression to examine the visualization, the trend of average sample size over time of a specific stage. This demonstration will elucidate how these techniques allow for understanding trends and potential future value based on historic data. As you can see here, we have used the California as a constituted state, where we have represented with a trend line and how it will affect in the future. Subsequently, we have done linear regression application to forecast depression percentage over the top 10 years per state. In this section, we have emphasized how such predictions offer valuable insight into potential future trends. Based on historical data patterns, we have predicted the growth and decline of various states, depression rate, which will potentially give us an idea if it is going to increase or decrease. As we can see here, there was a middle range in Texas, but with the help of the data, we are able to predict that there is a very high decline in rate of depression and causing a risk to health in Texas. Here we have used linear regression because as we were not able to perform time series analysis, so we have to subsequently change our analysis and model to work on linear regression. Next, we have worked on the ARIMA model, which is auto-regressive integrated moving average model for forecasting depression percentage across the states. This iterates process of data handling, model creation, future value forecasting, and visualization. The aim here would be to present a comprehensive overview of both historic trend and predict future trajectory, enhancing understanding of data dynamics. Through the presentation, the emphasis would be on particular application explaining each snippet. Here we can see in the bar graph, like there are actually multiple lines, and in Amari we have created an fit model. Then we have predicted depression rate while taking a data frame and appending it and combining the original data and prediction to plot a bar chart. These are the things we have done to perform an analysis and prediction for the model. Now we'll ask my colleague Lakshmi to explain us further about the code. Thank you.
Hello, Professor. My name is Lakshmi, and I will be going through the remaining codes of development that we have done for this project. So this is one of the codes that we have prepared, that is curation of data for the smokers. And here we can see that we have added the mean data value distribution for the class, that is tobacco use, which comes into smoker category, and we have taken the mean data value for it, and this is specific to the state of Texas. And distribution of data value footnote symbols in Texas. So here we can see that these are the footnote symbols and this is the count for it. We can see the similar thing on the code, which should be right here. So here we can see that we have taken the subset or smoker data set, which is basically a subset of the original data, which has classified the class as only smoker category, which is tobacco use, and we have grouped it by the class and the data value, and we have taken the mean of the data value. We have given a figure size for this, and we have also sorted the values for this plot. We have added the labels for it, X label, Y label, and also the title for it, which is distribution of mean data value by class in Texas, and we have done plot.show. So here we can see that the mean data value for tobacco use in Texas is basically at between the range of 0 to 25. Then we also have done the distribution of data value footnote symbols in Texas. So here also we have done a similar thing where we have taken data value footnote symbol and we have just taken the count for it, and we have showed the labels for it, titles for it, as we have shown in the previous graph. And here we can see that these are the data value footnote symbols, and the count for this ranges from 0 to 2500, while for the other two it ranges between 0 to 200. Can also quickly run this code and show the output of this one, which is right here, and the similar for this one that we have generated. So this is the mean value. The next thing that we have developed is the bar and box plot of the smokers. So as you can see here, we have done a box plot as well as the histograms to show the sample size and data value for all of the records that we have in our data. So here we can see that we have just taken a subset of smoker and we have set sample size, data value, and we have plotted a histogram for this one, and the same we have done, we have just plotted a box plot for this one. So here we can see, if I quickly run this again, here we can see that the sample size ranges closely between 0 to 6000 roughly, and the data value is placed very closely between 0 to 80, 0 to 100. So here as we go to the box plot and we see that the sample size for our data set has a huge range, which comes from around 0 to like more than 15,000, but the data value is closely related and it's just present like between 0 to 100. Then we have also done a predictive analysis of smokers. So here we have shown a scatter plot for the top 10 locations with the most observations which have smokers in their category. So most number of smokers. So we have plotted this via the year and the sample size that we have got for different locations, and we have only shown the top 10 locations, and we have also taken the sample size for this one. So for the sample size here, we can see that the summary stats, we have just taken the same subset that we were using earlier, and we have taken sample size and data value, and we have just described it to give the summary stats for this one. And this is what the summary stats looks like at the moment. Then we have also done the predictive model for the tobacco, which is right here. So here we have created the subset which is data, and we have filtered it by the question ID, which says it should only take the class question IDs where it says smoker, and we have created a copy of this. And then we have taken this subset and we have taken the column sample size, where we have replaced any of the string values with an empty space, basically blank, and converted it to float. Then for the year also, we have converted this column to a particular format, which is percentage and year. So it should be of this format, and then top 10 locations, which says it's pulling out the location column and it's taking the values and count, and top 10 index. So this is only it. This top 10 locations will pull only the top 10 locations. Going ahead and plotting this subset that we have created for the locations, for the sample size and for the year, and we are creating a scatter plot for this one. So here we can see the top 10 locations for most observations with smokers. Here we can see how densely it has been populated, and based on the scatter plot we can say that these are the top 10 locations for the most number of smokers. Then we have also started creating the dashboard for our final presentation, which looks like this. So currently we have just plotted the class topics and all of the filters, based out of which we are looking at the tobacco distribution based on the age. So this is the progress that we have done, and we will be posting the YouTube presentation final link on the final presentation. And yes, thank you, Professor.